Hello everyone, and thank you very much for watching this live event, lesson number 3 from the Spring Security Fundamentals playlist update, of course. We are here to discuss authentication from the first step to the user details service. Let's call it to the last step actually, which is, but you don't know yet, you will find out in this lesson, storage of the authentication object in the security context. So thank you very much for being here with me, and of course, as usual, don't forget you have a live chat there, so you can start discussions and ask questions in the live chat. I say hi as well. If you don't, if you are not here with us now live, you can still ask questions in the comment section of the video. Or you can always find me on LinkedIn and Twitter as well, so don't forget that I'm all over social media. With that being said, I think it's enough for our introduction, and today I won't forget to share my screen. So let me share my screen and start with a description, with a visual description of what we are going to implement today, and then as usually we will open our IntelliJ project, and then I'm going to start coding and explain you step by step how to implement authentication. So you already know that we are dealing with web applications, and you know that when the HTTP request enters the application, it enters through the filter chain. So here you have multiple filters. So you have filter 1, and then the request goes forward to filter number 2, and then at some point it reaches the controller, which is where we have the method annotated with get mapping, post mapping. You already know that from the Spring Fundamentals playlist. So this is the controller here. So what we also know is that one of these filters, when we discuss about authentication in Spring Security, one of these filters is responsible for delegating to the entire authentication mechanism. So that means that this filter here, it's actually the authentication filter, and it delegates to a component that's named Authentication Manager. And then the Authentication Manager further delegates to a component that's called Authentication Provider. And you also know that you might have multiple authentication providers, and then in case they need credentials like standard username and password, then we have some dedicated components for the retrieval of the username and the user details, which might come from a database, as we did in the previous lesson. So this is the user details service, and we have a dedicated component that's called a password encoder, that's dealing with encoding the password and validating that the password matches. So what we are going to do today is that last time in lesson number 2 we did implement a user detail service, and we did make this user detail service go into a database, retrieve the user details, authorities. We even managed to create that many-to-many relationship in the end. Still didn't know, or still didn't figure out why it didn't work with custom column names, but that doesn't matter because it's not related to Spring Security. We basically customized all this part. So all this part is what we did in lesson 2. Now, what I want to do is I want to show you what you do in case you want to implement a custom, completely, purely different authentication mechanism. And why is that important? Well, I don't expect you will need at some point to really implement your own authentication, because you will usually rely on something, some mechanism that's there in the specifications, like HTTP Basic, like OpenID Connect, and the OAuth 2 that we will discuss at some point in the future, like certificate authentication style. Anyway, you will most likely rely on something like this. It's unlikely that you will really implement something custom, but Even though that doesn't mean you shouldn't know what's behind the scenes, I find it very importantly about any framework to know not only how to do some stuff and just assume that's working because that's the way you learned how to do that. I mean, I add that get mapping annotation on over the method, and I know that I did expose it through a get endpoint. That's not enough. Same in Spring, in Hibernate, in any framework. My advice for you is do try to also understand what's behind the scenes. So this lesson is important not because I expect you will often implement authentication, custom authentication mechanism from filter to the provider yourself, but it will give you the perspective of the entire design behind the scenes. And that's because we saw how we implement our custom user detail service, and today you will see how the rest of the world works. So that means, and we are still missing some component here. At the very end, this is the security context, and this is where the authentication will be stored. And I will redraw this entire schema because I totally crowded it with irrelevant stuff for today. But while we deal with what we implement, I will come back to my board and I will try to explain you what exactly are we implementing and why. So step by step, you know exactly where we are. But with that being said, I guess it doesn't make a lot of sense only to see some drawings, especially because I'm not good at all at drawing things. So I do rely on what I know the best, and that's writing code, of course. And that's Spring Security 2022 C3 E1. I will try to stick on the same namings that we gave to our projects. And today I think the only thing we really need is to have some Spring Web dependency. We do need, of course, the Spring Security dependency because that's what we are discussing here. And maybe we need Lombok. I mean, I can anytime generate the constructors and getters and setters, but yeah, why not? We can use Lombok. I like using it in real world apps. So 1 second, just to drag the window which opened on one of my other screens for some reason. And for some reason, computer seems to be very slow today, but well, I guess that's life. So let me open it. I just created this project and it takes just a bit to index. So I do expect that will happen. Okay, and let's just wait a bit more. And while that happens, I will answer also the question for Mikhail. I'm new to this playlist, but I thought you already had a playlist on Spring Security. Yes, but that was 2 years ago and a lot of things changed. And now I'm trying to remake it to explain, of course, how Spring Security is today. And you can expect from time to time on my channel to see remakes of different playlists when I feel that things changed too much. Then I try to make sure that I give you always the updated information, and that's what I'm doing now with Spring Security. So that's a great chance for everyone who didn't see that playlist to see it now from zero. It's a great chance for everyone to meet again live with me and to have you live here, which is absolutely great because we can discuss and you can ask questions. And it's a great chance, of course, to always give you the latest because technology changes very fast. So 2 years, it's already a lot in terms of frameworks such as Spring and Spring Security. Spring fundamentals, not really, but Spring Security, which is not quite fundamentals, and such other frameworks which are not necessarily fundamentals, they tend to change behavior more often. So with that being said, at the very end, we know what we need. We need a controller to test everything. So let's start by creating a controller, and that's basically the resource we will secure. By default, it's already secured by being authenticated and requiring with HTTP basic authentication with that randomly generated password which Spring Boot will print in the console. We already know that. I won't go through that again. Lesson number 2. In that lesson, we already discussed this. Today, I will start from the filter. So that I'm just creating this controller to have something to secure, because I will need to test somehow whatever I implement here. Otherwise, you will not believe me. Or you will believe me, but I still don't. I'm still not happy only with that. I want to show you exactly that what I say, it's working exactly how I say it. So a very simple endpoint demo, and that just returns a string, and that should be it. Okay, fine. What do we start with? So maybe going back to my remarkable, and let me actually clean completely the board. Okay, because I want to show you now where we are. So now what we are doing, we are at the filter level. We will implement a filter that we will call custom authentication filter. And this is where the HTTP request will go. And of course, the response will somehow go back. And we don't really care what's after this. We know at some point it will reach the demo controller. So this is the demo controller. So this is where we added that demo endpoint. Okay, so in between we have other filters. For example, we have the CSRF filter you will learn in the next lessons. We have the authorization filter, of course, where we apply the authorization rules at the endpoint level. But today we don't care about those. Today we implement this, and then we implement an authentication manager, and then we implement a custom authentication provider. And the whole idea of the exercise is that somewhere on the server side we have a static key, and we want the HTTP to use that key to get authenticated. So we want that key to be used to get authenticated. So only a request which on a header that we will define contains the key, only that request will be authenticated, and we will have a 200 OK on the status back and the response. So we don't have users, we don't have passwords, because basically that's what we implement, the custom authentication. So let's do that. Some questions from your side, meanwhile, maybe before I go back to code, I can answer them. So let's say, my book 2 years back. Yeah, exactly. It's kind of still having good stuff there, but if you are new to Spring Security, you might not know exactly what you learn and is deprecated, and what you don't learn and is not deprecated. So there will be a second edition soon that I'm going to start probably this fall. If we have multiple authentication provider, which one will be picked? That's what we discussed today, Mohammed. So stay here with me and you will find out which will be the one picked. And the last question, if we have multiple authentications, can we have that? Yes, you can have that, but because the authorization part is something I will discuss in the next lessons, somewhere in the next lessons, maybe when we reach the OAuth 2 part, I will show you how you can, for example, have some endpoints that use OAuth 2 while some others use HTTP basic or X509 or any other authentication method. Yes, you can have that, but I will show you that later in the next lessons. Cool. With that being said, where were we? We were at creating the filters. So I'm going to say here config, because you already know that we will need a configuration class, and I will call this configuration class, like I did in the previous lessons, security config. Of course, I will annotate it with at configuration, And then what I will define here, because as you have seen, we don't have users anymore. Our custom authentication just relies on a key. You can assume for this the sake of the simplicity of the example, here is our very, very, very secret key. Never do that in a real world app. Secrets should not stay in the application properties. They should be they should be defined with variables and stored somewhere in a vault. But the result at the application level is the same. So for us here, because we don't have such an infrastructure, I will simply put our very, very secret key here, which I named it secret. So that's what we expect to have on the header of our request. Okay, so that's the idea. I want to implement an authentication mechanism where the request contains a header key with the value secret. If they don't contain this, then the authentication fails. So that's clearly a custom authentication. There is nothing like this. It's something that I customly create for my application, for my example. So I can't use HTTP basic or X509 or OAuth 2. I need to create it from scratch, and this is a very good exercise again to show you the full design of Spring Security authentication mechanism. So say security filter chain, you know, it's the bean that we need to put in the context for the configuration. So previously, guys, we were extending web security configurer adapter, but remember, web security configurer adapter is deprecated, so you don't use that anymore. So if you write web security configurer adapter, you can see it's crossed out with a line. It has been deprecated in the latest Spring Security versions. So now the only way in which we can define is having that HTTP security bean from the context. We inject it and we define a bean of type security filter chain, which at the very end will be created with a builder. So the only thing you need to, like, in the end return is the result, the return value of the build method, and I need to throw that exception as well. So what I'm going to do here is creating that filter. So I was here on my remark, I was telling you I'm creating the filter. So here I am now on the filter. That's what I'm going to build. And that means I will have to add a filter at, and then define where I add the filter at the position of the authentication, usually where the authentication username password authentication stays. So that's what I'm going to do. So I need a filter, and then the second parameter will be username password authentication filter class, which just tells in the security filter chain, in the filter chain, let's call it simpler, filter chain, add a new filter at the position where the username password authentication filter would have stayed, which is the filter that HTTP basic relies on. So we will have to replace it with a new custom one that works exactly as we desire. So let's do this in the config. I will create a package security, and then in the package security I will create a package that's called filters. And observe, guys, that I'm very organized. I'm always very organized with my classes and my packages. I never put all the classes in one package and stuff like that. I'm usually very careful with how I'm designing how I'm organizing my packages and classes, because in a real world app where you have a lot of classes, it makes life a lot easier to find a class if you are very organized. And then the filter, I'm going to simply call it authentication or custom authentication filter. Okay, and then theoretically I should directly rely on the filter interface. Which is basically this one here. If I choose to do that, I simply need to override the doFilter method, which is the only abstract method. But what happens is that when I rely on the filter interface, I don't necessarily know that the filter will be only called once. So one thing you should remember is that in the filter chain, there is no guarantee that the filter will be only once called. And if you really want to do that, if you want to make sure that the filter is only once called, what I do recommend you and what I'm usually doing is I'm extending the once per request filter. Instead of the doFilter, it has a method that's called doFilter internal, if I correctly remember. Here it is. And then what I'm also going to do is I'm making this a component. Let me put the parameters one under the other. And for the moment, I'm not doing anything with this filter. At some point, what I will need to definitely do is propagate to the next filter in the filter chain. But I want to do this only when the authentication works. So I will not leave it like this. Well, fine enough, being a component, it means I can go back to the security config, and then it means I can simply say private final custom authentication filter, and then of course I need a constructor if I chose to make the attribute final. So I added the Lombok annotation, so I can say all-args constructor here, and then I will fill in this parameter at this point. And there is one more thing I'm going to do, but I'm not going to explain it in details because it's related to authorization, and authorization is something that we will discuss in the next lessons. I will need, in order to be able to prove you that the authentication works fine and we have everything, I will need to make sure that I secure my demo endpoint, and I'm going to do this way. I'm going to say authorize requests. For any request, the app should require authentication to have been done. So then I need to add an and here. But the idea is you don't, for the moment, don't worry about this. So don't worry about this line. It's not difficult to understand, of course, but just that I will explain authorization at the endpoint level later, and this line 21 is related to authorization. But for the moment, the only thing you maybe need to remember is this line only makes that demo endpoint to require authentication. Why didn't I need to do that in the previous lesson? So why didn't I need to add this line in lesson 1 and lesson 2? Is because in that case I was relying on the default configuration. So if you remember, we only defined the user detail service in the password encoder, and we relied on the default configuration, which implied anyway that all the endpoints were requiring authentication. So that's why in the past lessons I didn't need to add this row. You didn't see it, but now you will just see it. You don't worry about that. I will explain it in details when we reach the chapter about authorization. So now what you can read here is actually I added a new filter at the position where the authentication filter lies usually, and then I said that all the endpoints, to call any of the endpoints, you need to be authenticated, and that's basically everything I needed to do. So now I can go back to the filter, and then I'm going to extend to the next member of the design. So I created a filter, and now further I need this, which is the authentication manager. So I need to have an authentication manager whose role is delegating to a provider. Well, in case you only have a provider, you can make the compromise where you completely get rid of the provider and you implement the logic in the manager. But the design of Spring Security is made in such a way in which it allows you to easily have multiple authentication logic through having multiple providers. And that's basically why I do recommend you, even if you have only one provider, well, if in the future you will need to add one more authentication style, then it will be much easier if you follow the correct design. So do follow the correct design. And now basically let's create our authentication manager. So that's step number 2. In the security package, I will add a package called managers this time. And I will call this custom authentication manager, which my custom authentication manager will be a component as well, which means it should be pretty easy for me to add it as an attribute in the filter. Okay. And to really be an authentication manager, of course, I need OAuth constructor here as well. And to really be an authentication manager, I will make sure I implement the authentication manager interface, which you can see here, which of course implies I need to define the authenticate method that takes care of the authentication itself. So what will actually happen is that from the filter, now I can say something like this. I can say create an authentication which is not yet authenticated. Delegate the authentication object to the manager, get back the authentication from the manager. If the object is authenticated, then send request to the next filter in the chain. So these are the steps if you want to, like, some quick steps: 1, 2, 3, 4, 5, 2, 3, 4, only 4. So that actually means I will have to, like, say something like var a from authentication, custom authentication manager, authenticate, and then provide something here which should of course not be null, but I don't have an option yet. And then what I need to say, if a is authenticated, so if the mechanism managed to authenticate a, then in the security context holder, get the context and set this authentication so that it can be later on used by authorization, the authorization filter, and by authorization configuration. So later on in the next lessons we will discuss authorization, and the authorization relies on this object. So this line is a very important one. This line is where at the very end we store the authentication somewhere, so that the authorization mechanism can check out who authenticated, and then based on who authenticated and their privileges, they will be granted different access in the application. So that's basically the logic. And of course we do observe here what we are missing. We are missing an authentication. So that's what I'm going to do here, is I'm creating a package authentication. And in the authentication package, I'm going to create my custom authentication, which will implement the authentication contract in Spring Security, which, as you will see, is really a nasty contract, because, well, it hasn't been really created smartly to fulfill the interface segregation principle from the solid principles. This is an example of how not to create a contract. So in the end, what's actually interesting about an authentication? Well, you don't even know you really have a principal. You can do that. You don't even know you have details. So why having a method on details here? This should have been segregated. Credentials, this should have been segregated somewhere as well. The only really important thing, for example, in our case, we don't even have a name, do we? So we don't have a name because our authentication only implies to have a key. That's what we discussed. So the only important thing is the authentication being authenticated. That's the only thing we care about here. So that's why theoretically, if this contract would have been smartly designed from the beginning, the only thing important here would have been the authentication part, which the Spring Security mechanism relies on. So that's to remember. So that's what I want to say is that because of that, I will simply have to leave all these methods not implemented. I don't care about them. But what I'm going to do is to make sure I implement, say, private final Boolean authentication, and then say all args constructor. And then why I'm not using a record? I could have used a record for this one, of course, because it's only like I only have this field here. So for this one, I can use record. For configuration classes, I don't think I can use record since I expect they might be at some point aspected. And remember that records are final, which means that aspects on records don't work, which generally means you will probably not use them for classes like services, where you will maybe have transactional above, configurations, which can be aspected as well in Spring. So I don't recommend the use of records for this kind of classes. What you could have used records for, like you can make this one a record if you want. It's probably the same thing, but since I anyway used Lombok in my application, I will skip on using records because it's not the subject of today. What do you do if your user's credentials are not valid? Do you throw bad credentials or return null? Let me get that. Actually, that's a good question because I'm not sure if I'm going to get to that in this video, do I? I don't have users here. So if the credentials are not correct, well, in this case, I will throw definitely an exception, so I don't see any reason returning null. I guess you mean from the authentication provider, because from the authentication provider, if you return null, that means the authentication might still work with the next authentication provider. So it depends exactly on what's the logic behind the scenes which you want to implement. But for me, wrong credentials usually mean failed authentication, which means throwing an exception of usually the type authentication exception. But in our case here, so that's how we started. We don't have users at all, because that's what I want to say. Let's focus on something completely new where you would have from the very beginning design everything. So in our case, basically it's only the authentication and potentially that key. So we might actually need that key, don't we? Key which was a string, because somehow the key needs to reach the provider. So I'm going to sorry for that. I'm going to actually, I think it's easier just to say like this because I'm using Lombok. Okay, getter. And then what I'm going to do is I'm going here and I'm creating an authentication of my type custom authentication. Is new custom authentication. Okay, and whether I actually have the OAuth constructor here, because I said, that won't work actually, isn't it? So for this one it might be final, but for the other one it will not really work because the authentication needs to change. Either needs to change or you need to recreate it, which is fine as well. So I'm not sure here which would be a better approach. but maybe in this case it's just enough to create a new one. So yeah, let's actually do like this in this case. Let's see if it's working. So I'm saying here is authenticated, and then I don't have an authentication and the key, and then I have an all constructor. This can work, but it means I create an immutable authentication, and then I need to return a new instance, which will potentially not contain the key, because we consider it that some secret. Okay, so then the key here, and then getters and setters, which I already created. Did I? So that means in that case, first of all, this will contain the key and the false for authentication. Oh, the other way around, since they are. So authentication false, it's not yet authenticated, and then the key is string value of from the request, which comes as a parameter for the filter, doesn't it? Get header, and let's call the header key because it's easy. And this one now goes here, and now we have step 1, create an authentication which is not yet authenticated but contains all the needed all the needed details for creating the logic. And then you call the manager and you get the authentication, and then you get the authentication, and then if it's authenticated, then you set it in the security context, and then you filter further in the chain, only in that case. So that should be fine. Okay. And then the next thing is going to the manager. But to have the manager here, we actually need to have a provider. So I'm actually going to say providers. And then say custom authentication provider. And then this will be a component as well. We implement authentication provider. And we do have to define the two methods, the couple of methods that define an authentication provider. And let's start with the first one, because this will also answer one of the questions you had. So it's how does the manager know that a specific provider is the one to be used, and that's related on the authentication type. So you see here the first thing that will be needed is to implement the supports method, which tells for which kind of authentication is this provider. So what I can say here, for example, is I can say custom authentication class equals authentication, and that's it. So that's how I know actually how that's how the manager knows that this is supported. And then the authentication implementation itself, that's what will come here, where I will be able to say custom authentication is custom authentication, and I cast it to get the key, and then I say take the key from the properties using the value annotation, and then this is the key. Okay, and then says string header key is get key if key equals the header key. Then we need to create, say, a custom authentication result, which will be true and where we don't store the key anymore. And then that's what we return. And of course, I could have actually made it even simpler, just put the return here. And then say else, like if it doesn't go through this if, I have to throw a new, and I will use an authentication exception, and I'm not pretty sure exactly what I should use here because I'm kind of in a custom implementation, which doesn't really make sense. But we can say use bad credentials exception. So let's just say we use the bad credentials exception. Normally, maybe I could have even created my own exception for that. So I think that's how our provider, very simple provider, should look like. And then in the manager, finally you can just inject the provider, say private final provider. And yes, in my case it's only one, but that doesn't stop you have multiple if you need. And that's where I should say something like if provider supports authentication, then provider authenticate the authentication and return it. Okay. Authentication get class. Okay. So that's one of the cases. So we do actually return if it doesn't support. Then say if you would have had multiple providers, then you would have iterated through all of them and only throw an exception at the end. But now since we only have one, I will just go and add this exception at the very end here, where we theoretically already went through all our providers because we only have one provider. Our very simplistic example here. So that's how it goes. And now going back, so I think that's basically it, because going back to the filter, we already implemented the call for authentication in the store in the context, so that should be it. And then next thing I will do, of course, is I will show you how it works and see if we didn't make anything wrong, then it should really work. But before I'm going into that, I see you already have more questions here while I was focused on implementing the logic. So let's see if I can answer you. So why exception thrown in filters cannot be caught by controller advice? It's a very interesting, not related to Spring Security, but very interesting question. So it's because the REST controller advice, how the name suggests, it's an advice, which means it's an aspect. So the REST controller, when you have a REST controller advice like this one here, REST controller advice, this is an aspect over the bin of the controller. So that means that the advice can only see what happens here in the controller, because the aspect is over the controller. If you throw an exception in the filter chain, boom, okay, it will not be caught by the REST control advice, because the REST control advice only sees what's at the boundaries of the controller, not what's before the controller. So this exception here, this bomb here, I'm not good at all at drawing things. This is not seen by the REST control advice. So okay, filters actually before the HTTP request, exactly, that's what I tried to explain. And then one question in the Java servlet means thread So why it's more than thread out of context? I'm not sure if I understand the question. So no, I'm not sure if I get it. When it says servlet, it's actually on this diagram. It's actually somewhere here. Here is that dispatcher servlet, okay? And that dispatcher servlet, indeed, when it's called by Tomcat in our case, it creates a new thread for every request, which this one delegates further. And at the very end, the request reaches the controller. But that what I was saying. The REST control advice, it's an aspect over a bean, and it's an aspect over the bean of the controller, so it can only see what's up to the boundaries of the controller. It will not see what's before, so the filters themselves, okay? And then why is the HTTP param in the security filter chain from security config class highlighted with red? Oh yeah, that's a bug in IntelliJ, so don't worry about that, it will work. It's just I didn't try, I didn't have time to update. I know I have an IntelliJ version that is a little bit older, so 2021-3, and I didn't have time to update it. But the problem you see here, it says there is no such bean in the context. You will see that's working. When I will start the application, it will work. It's just the problem with IntelliJ not seeing correctly the context, so don't worry about this. This is an IntelliJ bug, it's not on our application. And then in Lombok, if we use required args constructor, then it will only pick the final fields. Exactly, yeah, you can do that. So if you have final and non-final fields in Lombok and you want to create a constructor only for the final fields, then what you can do is you can use the required args constructor. Cool, let's start the application and see if we manage to actually do something here. And moreover, I would like to actually use some breakpoints. So I will, first of all, I can show you it's working as desired, make sure that it's working as desired. And then I will place some breakpoints to show you step by step exactly how it works. And then you will see how this integrates, of course, with our framework. So it's starting now, and it says it started, and then I'm just going to pick my postman here, and I'm going to say I want to call the demo, so HTTP localhost demo, and in the authorization let's use no for the moment, so we try to call it without an authentication at all. And of course the expectation is it shouldn't work because we explicitly stated in the configuration that we need for the endpoint to have to be authenticated. So you can see here clearly that we get back a 403 forbidden, while in case we have some authentication. Our authentication means have a header key, that's how we call it, and then with the proper value, and you send it, then you have a 200 OK, and you get back the response, which is exactly what you expect. Of course, if you don't have the correct secret, then you should still get a 403 back, hopefully. Which is not what happens here, because probably we didn't catch an exception or something. So I was actually throwing this exception, which should have, from my point of view, resulted in a 403, but that's not a big deal. Like in this case, you can just go and make sure that you set the status yourself in the filter. But anyway, the idea is it's working as expected, and I want to actually restart it with debug mode, and then I want to show you step by step what's happening here. So once my application starts with the debugger attached, I will just run again the authentication with demo with the correct key. So I'm going to send the request, and you see that we ended up on the first line of the filter, which is what we expected. And then when you go on the next line, you will see here that the key has the value demo. So that's what we took from the header of the request. And then it creates the custom authentication, which is the unauthenticated authentication object. It creates it, and then it calls the manager. And then actually we can see it further here. It entered the manager. And then it checks on the provider. It says, does this provider support this kind of authentication? And this way you can have multiple authentications, because you can have like an authentication, say one implementation. If that's the one coming and it's not supported, then it will go to the next one, and so on and so forth. And I think we can basically, in one of the next lessons, we can try to implement multiple authentication as well. But if you are eager to see that before I'm reaching into it at this stream, I think you can still find a video on the playlist from 2020 where I implemented multiple authentication mechanisms in the same application. So now you basically see it goes here. The type is fine, so the condition is true, so it enters the if. And then of course next thing happens, it goes into the authenticate, it takes the authentication, takes the key, puts the condition, and something is wrong, because it shouldn't have gone here. Secret, and then the header key is demo. Oh, and it's basically, sorry, it's my fault. I used the wrong value, demo instead of secret. We will see actually that this throws the exception. Okay, fine enough. And if I would have used the correct one, if I would have used the correct value, then the flow is the same. But then here it goes into the authenticate, and it goes into the if, and it returns the authenticated authentication. And then it says if A is authenticated, which is true, stores the authentication in the security context. That's where the authorization rules will take it, and then delegates to the next filter in the chain. Okay, so that's basically how it's going. So if I'm just going to draw it one more time, say I'm going to actually erase everything. So the request goes into the filter, and then it goes into the manager, and then it goes into the provider, and it returns here the authentication is not non-authenticated, so the authentication object goes here, and then it goes here, and here it's where it becomes authenticated, and it goes here again. Sorry, that's true, and then it gets stored in the security context. And then of course, after it stores the authentication in the security context, the next thing is that in the filter chain it delegates to a next filter. So the request goes to a next filter. So that's basically it. That's what we expect to happen. Okay, so the reason I asked about the exception in filter is actually related to security, because I have a problem where the JVT expired exception been thrown in the filter. Yeah, in that case, which is the case, you will not be able to catch it with a REST control advice indeed. So that's true. What you can do, I'm not sure it was the case there, because I don't usually recommend go over the OAuth mechanism, but if you really want to hack that in, of course you can still probably place a filter somewhere before and find a way to hack that, but I don't really recommend that. So be very careful when you do something like this. So I don't want to say I advise you do that, because I'm not sure what's there in your code. What are records? It's a subject that I would say we don't discuss it in this video, because it's a subject mostly on Java 17, but you will find a video on records if you search it on this channel. So just search for records on this channel, and I'm pretty sure I already created a video where I explain how records work. So go there and find a video where I detailed about records. I'm pretty sure you will find one. Okay. So yeah, that's basically how we managed to, at the very end, get with the authentication. And then you know what happens. The next filter is the authorization. And the authorization filter, what it does is it takes from the security context the authentication and applies the rules. So this is one of the things that we will do next. So now theoretically you know what the entire authentication mechanism is in Spring Security. So it starts with a filter, then it continues with an authentication manager, and then it continues with a provider. If needed, the provider might need and work with a user detail service bin and the password encoder. Okay. And the authentication goes back, it's stored in the security context, and then the request is delegated to the next filter, which one of them will be the authorization filter. What's the relationship between the security context and the session? There is no relationship. The security context is actually linked to a thread. So each thread, which means every HTTP request, you know, the request in a standard non-reactive application creates a new thread per request. So each HTTP request creates a thread, and each thread, when it uses the security context behind the scenes uses something that is called thread local. A thread local is an object provided by the JDK which makes sure that every thread sees only what they stored. So if you have two or more threads, which happens in a web application at the same time, so because for every request you will have a new thread, then the thread will only see its own data in the thread local. So in the security context, each thread will actually see their own authentication object. So because every thread will have a different authentication object in the security context, and every thread will only see that one because of the thread local mechanism behind the scenes. So there is no relationship between the session and the security context. The security context is per thread, per request actually. And I think that's basically it for today. So we managed just in time to have everything designed, configured from the filter to the provider, and to prove how we can implement our own key mechanism where we manage to authenticate the request based on a secret key that stays, in our case, somewhere in the application properties, but probably in a real world scenario somewhere in a vault. And I think now with this authentication mechanism being completed, we are ready for the next steps, which we will of course tackle in the next lessons. So I hope that, guys, I managed to answer all your questions. If I haven't, then keep those for the next session, because in the next lesson we will continue and you will have your chance to ask other questions, or you can, as usually, always put them in the comments section or find me on LinkedIn and Twitter if you can't wait till next week. But yeah, let's meet again next week, discuss more on Spring Security and fill more gaps to make sure that at the very end you are, all of you, experts in Spring Security. Thank you very much. I'm waving goodbye now and hope to see you next time for the next lesson. Cheers and have an excellent time for learning further.